Percent composition. The elemental composition of a compound. So how much of each element is composed in the compound. Alright, so we have our little formula here. So percent A, so the percentage of A equals the grams of A divided by the total grams of the entire compound,
which is the molar mass that you learned about last time.
We never do anything. Times 100. So here's our example right here. Calculate the percent composition of each element in cobalt-2 phosphate. So hopefully you can write that formula correctly. So we're going to find the percent composition of each thing. So in the first one, we're going to find the percent composition of cobalt. If you look at the formula, there are 3 cobalts. So it's 3 times the mass of cobalt, periodic table, divided by the molar mass of the entire thing. And then we're going to divide that, multiply 100, so 48.1% of that compound is cobalt.
And we do the same thing for the phosphorus and the oxygen. You have 2 phosphoruses, remembering that they distribute, and then 8 of the oxygens. On the percents, if you can try and remember to give like 2 decimal points, that's all we want for percents. If I've done this math correct, it looks like I may be a little off, you should end up adding up to 100%. I may have rounded somewhere in here that messed that up, because at a quick glance, the numbers don't look like they're going to add up. But you should be close to 100%. So the next thing we're talking about is empirical formulas and molecular formulas. Empirical formulas, you remember from first semester on one of those worksheets that we did, is your lowest number of ratio between elements within a compound. It may not be the exact compound formula, but it's the lowest ratio between them. So like if you have hydrogen peroxide, it's H2O2, that's your molecular formula, but the empirical formula for that is HO. And we got a little rhyme for you to remember how to do empirical formula, and yes, we're doing a practice example, and I've got plenty of examples to do in class next time. So our rhyme is percent to gram, gram to mole, divide by the smallest, multiply until whole, and we'll show you an example in a moment. And then you have your molecular compound, molecular formula. So to find out what your actual molecular formula is, you'll take the molar mass that will be given to you and divide it by the empirical formula molar mass, and then multiply, and we'll show you what that is again. You may have to find the empirical formula, and then it'll say, and the actual molar mass is yada yada, so you'll be doing both things at one time, or we may be nice and just give you everything like we are going to in this example coming up. So we have our first empirical formula example.
Alright, so these are the percentages that we have. 37.01% carbon, 2.22% hydrogen, 18.5% nitrogen, and 42.27% oxygen. If we look at our rhyme,
okay, so these are different percents. So remembering the rhyme, we have go percent to gram. So we just change our percent sign to gram.
Good afternoon, McEachern. Please listen up.
Sorry about that. Announcements came on. So you change all the percent signs to gram sign and just go with it. Gram to mole is just like when we did the mole to molar mass and all of that on the last part of this unit, where you take the mass given and divide by your molar mass. And let's go ahead and show you how that's going, so we'll talk through what's happening before the next interruption. So the first step, I took 37.01 grams of carbon and multiplied it by 1 and divided it by 12.01, and we'll talk about all this. You can see that you are canceling out your units. We'll do more canceling as we get into stoichiometry. So we divided that, and we got 3.081 moles. So we did that for all 4 things, and then when you look at it, you see that the moles of nitrogen was the smallest number. So divide by the smallest is the next step, so you divide everything by that small one. you end up, the one that you're dividing by is going to be 1, and everything else is going to be higher than 1, unless you had two things that were small. But you can see that none of these were, this one and this one were not whole numbers, so you're going to have to multiply until whole. Well, think about fractions. 0.33 is a third, 0.67 is 2/3, so we can multiply it by 3, and whatever we do to one thing, you have to do all things involved. So we multiplied everything by 3, and we got 7 carbons, 5 hydrogens, 3 nitrogens, and 6 oxygens, which is this formula right here. And just for giggle's sake, so you know, that's actually the formula for TNT.
Alright, the next one here says calculate the molecular formula of the compound whose molar mass is 60.0 grams, and the empirical formula is CH4N.
So you see from your directions over here, we'll take the molar mass given and divide it by your empirical mass. So you're going to have to do a little math real quick and find out what is 12 plus 4 plus 14. So that's 30. So you have 60 divided by 30, so that's 2. So that means your molecular formula is twice that. So let me go ahead and show that to you without my sloppy handwriting. Quit laughing at it, Alex. And that's exactly what we did. We took the given formula, the given mass, your empirical mass, and then we just distributed our 2. So our molecular formula is C2H8N2. And I guess the bell is telling us that we're done. See you in class.